And the second part, I will talk about why we are still talking about this, because after all, we should be much further with this. So, what is tb3? Well, let's look at the status quo first. With Tinderboxing, which is the machines that build LibreOffice again and again and send angry mails to developers if they fail with that. Then I'll go a little bit into how we might change that. And the question, should we trust the Tinderboxes if we distribute them to multiple people and have people build stuff on the Tinderbox at home? Can we keep the people in control at home? And is this still important? This is something that changed actually over the last year, I think. And then I'll show you like the web UI and what we're missing still and what had changed with making this able to work in Docker and source stack, which is hopefully interesting to our operations guys. So, yeah, this is how it looks if you try to develop LibreOffice. You commit something and suddenly you get 5 mails that tell you something is broken and you should fix it. And if that's a particularly slow Tinderbox that only builds like in a few hours, it actually mails a lot of people and said, one of you did something wrong. So this is less than ideal. Also, the Tinderboxes are all have different speeds. So if you break something on all platforms, after like 30 seconds, the Linux Tinderbox comes along and says, hey, you broke it. And then at some point later, the Macbox, an hour later, comes along and says, hey, you broke it. Of course, you fixed it already 5 minutes after the Linux Tinderbox told you about it. And then like 3 days later, the Windows Tinderbox comes. These builders, of course not, because, well, they are in someone's backyard and electricity might drop off or whatever might happen. So these, we trust the results once they come back, but we can't 100% rely on them to really come back because they might be switched off or whatever. So this is what happens. Actually, each Tinderbox, when it says I want to build something, has to make an estimate how long it would take. And once this time is over, the scoring, you see, is going up again. So this previously, this prevented someone to build the same build that another Tinderbox already was building. But if this Tinderbox really doesn't come back at some point in time, the score goes up again. And if a Tinderbox comes along and says, I want to build something, we would just reshuffle that and build again at the same point, because the first one was somehow, yeah, got missing. So with this is actually what we need. We need them to be comparable, and this is something that we didn't have solved the last time when we talked about that. Because something might actually break on a Fedora Tinderbox that does not break on a Gentoo Tinderbox or something. So we want to have that comparable. Yep, I'm going to skip over this one. I don't have that much time. So I'm going back to that problem later because that's actually a problem we solved in the last year. This is an example of how this web UI looks that we could export. It's ugly and you are invited to improve it, but so you see one branch and the status of each of the platforms and tests. And this is the more interesting slide actually, for example, because here on Linux you see, okay, we know this one builds, and then in the next step we try to build that one, and that broke. So at that point in time we got back and tried to find the first build that was breaking, and that is the yellow one. So we have, this one was good. This is the first one that I know was breaking, and this is the last one that I know was breaking, and there might actually be new commits which I haven't built yet. So you have a good state of where you are. With the Tinderboxes, for example, most developers work in Europe, so if something breaks overnight, there won't be that many commits. So the Tinderbox could go back in time and find exactly when something broke overnight, and in the morning you could see, this guy broke it. And that would be easy then to fix because you only have one commit. Okay, I'm skipping over that and that. So we can coordinate multiple Tinderboxes to build the same scenario. We can have one Tinderbox with a scoring watching multiple branches, and we can bisect while still keeping a watch on the head. So last year we had these missing bits. And the important ones are the ones here in the bottom, which is we didn't solve the problem that Linux Tinderbox is not always the same Linux Tinderbox, so you can compare that if you want to bisect. If something breaks on one machine, then it would also break on the other machine. And the most important point is I wrote this and expected it to magically appear somewhere in our infrastructure. Somehow that didn't happen. I don't know what you guys do, but it didn't happen like that. So the meshing setup is the critical point. And this is this. So I wrote this little script and said, well, that's done, and let's just run it as a daemon somewhere. And then I expected operations to magically sprinkle some fairy dust on it and it would just work. This is actually not how it really works. So if you do that manually, you would have to write down all the dependencies and stuff, and that's also painful. So you want to get into the DevOps way of things, which is documented with SaltStack, which is implicit. And then you can have actually a machine doing the setup of things, and you would not have to talk about all this and have this split. Plus one. So, what else happened since last year? Well, DevOps is not a hype anymore, everyone is doing it. We just heard the talk right before. The infrastructure is consolidating on SaltStack. And well, Docker was new last year, and everyone is talking about it now. So what can we do now with Docker and SaltStack? Docker allows you to have containers, which means you can write a little script and you get a machine up that is completely configured in a specific way. Think of it as a lightweight way of doing virtual machine. So this is Docker gets you the image. And the configuration, we are doing it with SaltStack everywhere else. So I created a machine that has SaltStack in a Docker image. And then you can actually deploy this stuff into that. And you can do something like this. You have your machine, type make once, and you get one master, this box that is coordinating Tinderboxes, and as many Tinderboxes as you want. Set up on your machine, you can actually test the whole infrastructure locally. Or if you just want to do some bisecting or just run a Tinderbox for a while, you can also just do that with one Tinderbox that's building against one master, which is like the minimal configuration. But the important point is, if you do this or that, you're still using completely the same setup, infrastructure, and everything. So if you are a developer and do some improvements here, we can immediately reuse them in operations and on the TDF infrastructure. And of course, with this configuration, you can also have set up these Docker images on multiple machines on different hardware and coordinate them with one master and just I mean, if you run this script, it lasts five minutes, and you have the complete image with as many tinderboxes as you want. And if someone has a 64-core machine with lots of gigabytes of RAM, you can actually use that to not only serve web pages. So with the Docker images, you have the image inside this container to be well defined in the same way. So if you run Tinderbox on that, no matter what the hosting hardware is, the image will be the same and you get reproducible results. And that means that you can, everyone who can run Docker can run a Tinderbox that produces results which are reproducible for everyone. It simplifies the client setup and it allows you to do on your local machine what we would do on TDF infrastructure. So again, you get the same benefits there. So let me stress the reproducibility issue on this. This wonderful sentence, everyone heard that before, especially our QA guys and everyone working in infrastructure. But it works on my machine, yeah. But that doesn't help you if it doesn't work somewhere else. And with this, if something, for example, breaks in Tinderbox, the developer also has the opportunity to just get the Tinderbox as it was configured. This Tinderbox was configured and go into the Tinderbox and see what exactly caused this breakage, instead of looking at some build log on some web page and trying to guess what is different on that machine than on your machine. And I can assure you, I'm a release engineer and do releases for Ubuntu. That's not fun, especially if the other hardware is something slow, like ARM or something. So with this, you can get this local and try to do the stuff local. So with this, we could also use that for Garrett, for the Garrett builders. But that's the second step, so that's a bit off. But in an ideal world, you could essentially, if what we discussed in the unit test roundtable yesterday, that you don't get verification because the Linux Tinderbox is missing, and so in that case you could just pull up the image and run it locally and have your local machine doing the missing verification still in a reproducible environment. Of course, I don't think we really want to do that because, well, that means trusting everyone to not tweak around in these boxes and blah, blah, blah. But what we also can do is deploy all this stuff into a cloud on wherever and just buy cloud computing resources and deploy it there. And I think this is getting cheaper and cheaper, and it's something we could probably easily use, and especially this scales, because if we are behind on building stuff, we just buy some machines for a few days and get up to speed again. So this is still off, but that's the long run we will. Okay, yeah. So these are the still missing bits, but I think those are actually small problems. The big problems are solved in this. Okay, so I have my half an hour, but I started 10 minutes late, so we have maybe a few minutes for questions, hopefully. Are there any questions? So, Alex, when do we deploy that?
I think Minnesota, the new infra platforms.
Okay. Any other questions? Okay. There will be another talk about automated unit testing and stuff, and I will try to use this for unit testing too, because, as I said, you can run this locally. So in that talk, I'll show maybe some slides about how how to do the running locally with this stuff. Okay, thank you guys.